This may look like a ball of flames, but its surface is an ocean of 10,000-degree plasma with waves, winds, and massive eruptions as explosive as 1 billion tons of TNT.
The surface of the sun is really quite chaotic. It's always boiling and bubbling. In particular, there are hot cells of gas that come out from the interior up, radiate their energy, cool, and then come back down. So this convection, as it's called, this boiling motion, similar to what you see in a boiling pot of water, is occurring near the surface.
We have never been able to look at the sun's surface up close. Until now. At this very moment, a new collection of satellites is capturing images of our home star. These unprecedented movies make you feel like you're an arm's distance away from touching the sun's visible surface, called the photosphere. This is where solar storms and other violent phenomena occur. As seen here, prominences can occasionally rip free and jet into space.
Our sun has an incredibly powerful magnetic field. But every now and again, those field lines become connected to hot spots on the surface of the sun. And as the gas and plasma boils inside the sun, those magnetic field lines can disconnect or break, releasing huge bursts of energy. And these throw up giant blasts of plasma that come out along curious-looking arcs. But these are actually following the magnetic field lines around the sun.
Eruptive prominences can occur in tandem with another solar ejection that can deliver a double punch if directed at the Earth. NASA's Solar and Heliospheric Observatory, or SOHO, recently took dramatic movies of coronal mass ejections, or CMEs. These massive bubbles of hot ionized gas contain up to 10 billion tons of solar material. They shoot out into space at speeds of several million miles an hour.
Coronal mass ejections are incredibly powerful storms. They can be as massive as 1 billion H-bombs, just huge amounts of energy. And sometimes those big blobs of plasma strike the Earth and lead to beautiful northern lights, aurora displays. They can also be very harmful to the Earth.
When large coronal mass ejections are blasted toward Earth, they can trigger geomagnetic storms. These blobs of ionized particles can damage or even terminate satellites, as well as fry our electrical grids. These latest images are chilling reminders that our sun's surface is a force to reckon with. And things may really heat up on our home star in the very near future. Solar activity runs through an 11-year cycle. In 2013, our sun will be at the peak of this cycle, called the solar maximum. At this time, the surface of the sun could create the perfect storm.
The sun has had in the past big solar storms that have knocked out power grids and our communication satellites. There will be more storms. They might happen at any time, or they may not happen, in our lifetime or even in the next millennium. We just don't know. That's one of the exciting things about studying the sun, is trying to be able to understand and maybe even predict the storms that we see in the sun.
The same micrometeoroids that can devastate space colonies also pose a lethal threat to spacewalks and entire spacecraft. Plus, in low Earth orbit, these rocky little gremlins have company, space junk. And all of these things are racing around at over 22,000 miles an hour. At these speeds, objects that are only a fraction of an inch wide can be deadly.
A micrometeoroid flying through space is a lot like a golf ball flying through the air, with these differences. The micrometeoroid is much, much smaller. And because it travels at hypervelocity, it's far more destructive when it hits.
But space is a big domain, and there are threats here that are unlike anything we have on Earth. Earth orbit, our edge of space, is generally divided into 3 parts. Low Earth orbit is an 1,100-mile wide belt that is closest to Earth's atmosphere and begins only 120 miles above sea level.
There are tremendous advantages to low Earth orbits. First of all, most of the manned space program takes place in that radius.
Start 1, 0, and liftoff of Space Shuttle Endeavour.
Also, spy satellites, communication satellites, weather satellites occupy that low Earth orbit.
Above low Earth orbit is a region called medium Earth orbit. This wide stretch of space is 1,200 to 14,000 miles above Earth. Many communication satellites are launched into orbit here, including global positioning satellites.
GPS satellites roughly orbit the Earth at about 12,000 miles, what we call a semi-synchronous orbit. So basically, they orbit the Earth twice per day, once every 12 hours. GPS is set up into 6 orbital planes. So if you can imagine a globe, there are 6 orbits positioned in equal spacing around the Earth, with roughly 4 or 5 satellites per orbital plane. And basically, that gives us coverage around the world.
GPS satellites sit at this altitude so that multiple satellites are in view from one location on Earth at any time of day. Medium Earth orbit is also home to the treacherous Van Allen radiation belts. These belts of high-energy charged particles can send a $300 million satellite spiraling out of control, or give a human being a fatal dose of radiation. These belts stretch out from Earth like elongated rings. Satellites are carefully placed in specific altitudes to avoid these destructive belts of particles from the Sun. Even farther out lies high Earth orbit, or geosynchronous orbit. If low Earth orbit is a busy city, high Earth orbit is rural farmland. 22,000 to 35,000 miles above sea level, satellites hover above Earth, taking in an unparalleled view from a distant vantage point. Here, over 2,000 satellites call high Earth orbit home.
These satellites appear to be stationary. They make a circuit around the Earth every 24 hours, but so do we. So we have the optical illusion that these satellites are sitting there in outer space.
A satellite or spacecraft is held in orbit by gravity. Earth's mass creates a gravitational force that deflects an object's path from a straight line. It might be assumed that Earth's gravitational pull loses much of its influence this high in the sky. But in low Earth orbit, Earth's gravity is only 2% less powerful than it is on the surface of the planet.
The way you stay in orbit is to go at a high enough speed or velocity that you are falling back to the Earth, but you're going so fast that your curved path actually never strikes the curved surface of the Earth. You just keep falling around the world over and over again. So you're not leaving the gravity behind, but you're being spun around the planet by gravity. It's what's holding you in this circular path around the planet, and it's making you fall back to Earth.
In theory, objects can stay in orbit forever, as long as they have enough speed to resist the pull of Earth's gravity. There are many things in Earth orbit that are dangerous. In October 2007, the U.S. Navy shot down an out-of-service satellite with a cruise missile before it re-entered the atmosphere. The reason? The satellite carried hazardous material on board, and had it crashed to the ground, could have poisoned thousands.
That hazardous material was 1,000 pounds of hydrazine, which is a standard propellant.
The operation was called Burnt Frost, and it was the most elaborate effort thus far to protect the world from a serious yet growing problem called space debris, or space junk.
Space junk is anything that's man-made that was put into space and is no longer functioning. Oh, we've got junk that's been up there for as long as we've been in space.
Like a junkyard slowly becoming cluttered with debris. From the first launch of Sputnik in 1957, debris has steadily been accumulating around planet Earth.
50 years into the space race, we have littered the heavens with our garbage.
And now, about 20,000 pieces later, Earth orbit has turned into a deadly debris-filled junkyard.
It looks like the Earth surrounded by a hive of bees.
Most of the space debris includes shards of rockets, satellites that no longer function, or pieces of an object that have broken up after a launch. Caught in Earth's gravitational pull, these pieces are traveling upwards of 22,000 miles per hour.
Say more than 10 times faster than a bullet.
A collision between functioning objects such as satellites or inhabited spacecraft and space junk could be catastrophic. The Joint Space Operations Center, or JSPOC, is a top-secret Air Force surveillance unit that makes it their business to track every object that orbits around Earth, including space debris.
We use a number of different sensors around the world, known as the Space Surveillance Network. It's a network of 29 stations all around the globe, radars as well as optical telescopes that track over 18,000 man-made objects in space. And that includes active satellites as well as dead satellites, and then rocket bodies that were associated with those launches, as well as debris, things that have just shed off. If they were to run into each other, it really would be a catastrophic conjunction.
To be tracked by JSPOC, debris must be at least 2 inches wide. There are much smaller objects that cannot be tracked. And in 2008, an intentional collision between 2 satellites created an international outrage and a cloud of debris that threatened low Earth orbit like never before. Space debris, and it threatens our spacecraft and satellites like never before. In 2007, the total estimated amount of space debris was 20,000 pieces, 14,000 of which were trackable. Then, in 2008, China's space program intentionally crashed 2 satellites together as an anti-satellite test. The international space community was outraged.
The 10th of January of 2007, the number of objects we were tracking was less than 14,000. Here we are 16 months later, and we've increased that number by over 30% to over 18,000.
The problem of space debris continues to grow, and collisions have already occurred between space junk and functioning objects.
One of them was a piece of debris that struck a gravitation boom on a spacecraft, severed the boom.
To avoid future collisions, JSPOC is in constant contact with NASA and other international space entities to inform them when a spacecraft or satellite might be threatened, so that the spacecraft could be maneuvered around the space debris. Fortunately, there haven't been any catastrophic collisions between inhabited spacecraft and space debris yet.
We've never seen a human-piloted spacecraft run into orbital debris and been damaged, but we've had some close calls.
Objects, no matter what their size, are always in danger of being pulled out of their orbits by orbital decay. Orbital decay occurs when an object loses speed caused by friction and begins to be pulled towards Earth by gravity. Atmospheric drag is the major cause of orbital decay.